take a look at types of solutions. These are our 3A.7 notes. And so if we take a look at these, most equations we have solved so far have only had one solution. However, there are two special cases. We could have a no solution or infinite solution. We're going to solve the equations below to see what happens when we can get each of these different types of solutions. So just to take a look at the one solution, just like we've done already so far, we're just going to solve the equation for x just like we would normally do. In order to do this, we're going to have to first start with distributing the 3 that we have here so that we can get rid of parentheses. So we get 6x plus 27 equals negative 5 minus 2x. And we would continue to solve, so I need to get all x's on one side and all the numbers on the other. I'm going to take and move the 2x over to be with 6x. So we're going to add the 2 over to move it across. So it'll cancel it out over here. And now I have 8x plus 27 equals negative 5. I need to continue to get the x by itself. So from here, I need to go ahead and subtract 27 to move it away from 8x. When I do this, we get that 8x is equal to negative 32. Last but not least, we're going to divide to get the 8 off of the x. And when I do this, x is equal to negative 4. So what does this mean? Well, right below it says this is only one solution that will make this equation true. So this is the only solution that will make this come out to be a true statement. Well, let's look at what happens when we have no solution. So we have a few things to do in order to start solving for x. One thing that we need to do is to get rid of the parentheses here by distributing the 4. The other thing that we need to do at the same time is try to make this as small as possible by combining our like terms. So that's something to consider when we continue to move on. So I'm going to rewrite that part of this. I'm going to distribute what I need to here. So I get 4x plus 12 and then plus that extra 1 that I have on the end. Now I'm going to start combining my like terms. So I'm going to take and I'm going to combine the x's that I have on this one side. And I'm going to combine the 12 and the 1 that I have on the other. So 7x minus 3x leaves me with 4x. And then I still have a minus 9. And this is equal to 4x plus 13. Well, now from here, just like we've been doing before, we would want to get all of the x terms on one side and all of the numbers on the other side. So if I start moving the x, and it doesn't matter which one I move now, I'm going to take and I'm going to subtract this 4x from this side. So in order to do that, I have to also do it to the other side. And when this happens, it cancels over here like we wanted it to. But on the left-hand side, 4x minus 4x also cancels out, and it leaves me with no x's. So I have negative 9 is equal to 13. Well, negative 9 isn't equal to 13. These aren't the same thing. And so we can show that by putting a slash through the equal sign. So this would read negative 9 is not equal to 13. So what does this mean for us? Well, about down below, it says there is no solution that will make the equation true. And we have a symbol for this because it gets to be a little annoying to have to write no solution every single time that we have no solution. So the symbol that we use for this is a 0 with a dash through it or a line through it. So this is what we would use to represent our answer for this kind of equation. We still had to solve it to know that it was going to be no solution. But towards the end we saw that, and this would be the final answer that I would want to give. Last but not least, we have infinite solutions, or many solutions. So let's take a look at this. We have parentheses that we need to get rid of, so we're going to start there by distributing that negative 2. So negative 2 times 3 gives me negative 6x. Negative 2 times negative 5 is a positive 10. And And then this is equal to 2x plus 10 minus 8x. Now I'd keep going because I still need to get all of my variables on one side and then all of my numbers on the other. If I look at the left-hand side, these two things can't combine together. There's nothing to simplify here. But if I look at the other side, I've got two x terms that need to combine together. So I'm going to start out by just copying down what I am not changing, negative 6x plus 10. And this is equal to 2x minus our 8x gives us negative 6 as well. So negative 6x and then a plus 10. Now, we're still following our rules. We still want to get all of our variables on one side and all of our numbers on the other. So if I start to move my negative 6x over to combine it with the other one, I have to add to do that. So I'm going to go ahead and add that over. It cancels on the side that I originally did it because that's what I was trying to do. And notice when we come back over here, we get the same thing. Negative 6 plus a 6 also cancels out. And so what we're left with is 10 equal to 10. And this is a true statement. 10 is equal to itself. So this works. So what does this mean for us? All solutions will make the equation true. Or any number that I want to plug into this will make the situation a true statement. And we also have a symbol for this. So to represent the infinite amount of solutions that I can have, we use our infinity symbol. So let's take a look at some more examples just to kind of apply this idea to some practice. So let's take a look. On number 1, we have 5x minus 3 equals 3 times 2x minus 1 minus this x. So my first step, I've got to distribute my 3 through. When I do this, 5x minus 3 just stays, but then I get 6x minus 3 and then still minus this x. So now I've got to keep going, and here I have two things that can combine together on that side. So let's go ahead and combine them. 6x minus an x leaves me with 5 x's, and I still have this minus 3, and here I've got 5x minus 3. Now, we're still going about and we're still trying to solve for x, so I'm going to move my 5x over to be on the other side. And when I do this, the first side that I did that from, it cancels. That was what I was trying to do. But notice on the other side, we get the same situation. 5x minus 5x cancels and leaves us with no x's. So now, when we drop down our numbers, we get that negative 3 is equal to negative 3. And this is true. This checks out. So our answer would be infinitely many solutions, or we can use our infinity symbol to show that as well. Whether you want to write it out or use the symbol, either way, we're giving that answer. Now, notice how we came all the way down to showing that negative 3 is equal to negative 3. But if we were to go back and look at the red part of our equation that we have here, 5x minus 3 is equal to 5x minus 3. Notice both sides of the equation are the same. We didn't have to go as far as we did here by trying to just get rid of the x's to show that the numbers were equal. Both sides were the same. So you could have stopped here and shown the same type of solution. So we wouldn't have to keep going. If you see that, you see that. If you don't, you don't. And we would just keep going anyway. So let's take a look at number 4. Down here, I have some parentheses that we need to distribute to get rid of. So I'm going to go ahead and do that. So I get that 8k minus 12 plus 1 is equal to 8k minus 11. So we have a little bit that needs to simplify here. So if I do that, I've got this negative 12 plus a 1. So I get 8k minus 11 is equal to 8k minus 11. Notice, this is exactly like number 1. We get two statements that are the same, and they're equal to each other, which is true. If they're the same on either side, it has to be equal to each other. This is a place where I could stop and now show that this is an infinite solution. If you needed to keep going further, then what this problem would look like is I would have 8k minus 11 equal to 8k minus 11, and I'd go about subtracting my k over, trying to combine my like terms. And when that ends up happening and cancels each other out, we still end up with negative 11 equaling negative 11, which is still a true statement, just like it was before, without having to do that extra step. You guys are more than welcome to stop at this spot and show this, but if you don't feel comfortable with that, you can continue to do the work that I've shown here in black to complete your answers. I would like to look at number 3, and then we'll give you the answer for number 2 in case you've just been going through and doing the examples on your own. So here I have distribution that has to happen on both sides now that I have two sets of parentheses. So I'm going to go ahead and distribute. 2 times 4 is going to give me 8, and then 2 times negative a is minus 2a. And this is equal to, we get negative 2 times a, which is minus 2a. Negative 2 times a negative 8 is positive 16. We're still trying to solve for a, so I need to move them to be on the same side. It doesn't matter which way I move. I'm going to go ahead and add my 2a here over to the other side. And it cancels on the original side, leaving me with just 8. And over with the 16, negative 2a plus a 2a also cancels out and leaves me with just 16. So now we have 8 is equal to 16. Well, we know this isn't true, so this is really 8 is not equal to 16, which gives me no solution. So put my circle with my dash through it, and that's my final answer. For number 2, if you are wanting to know what n is supposed to equal, we would get that n is equal to negative 6. Now, if you feel comfortable with this idea, because the only thing that's brand new is the fact that we have two new types of solutions, the infinite and no solution. If you feel comfortable with this idea and how to solve your equations up to this point, you're more than welcome to move on to the homework and get started on that to get it turned in. If not, I'm going to take a look at a few more examples, give you a few more answers, and then you're still more than welcome to move on to homework. So let's take a look at the back side of our notes. On the back side, we still have parentheses and things going on, so we're just going to go in and start solving these equations like we know we're supposed to. On number 5, I have some distribution that needs to happen, so I'm going to go ahead and take care of that. And when I do, I get 9c plus 15 plus 1 is equal to 2c minus 40. I'm going to keep going and simplify as I need to. And if I look on the left-hand side, I have some like terms that need to simplify. So 9c plus 16 is equal to 2c minus 40. I'm going to pick on my little guy and try to get it with my other c. So I'm going to subtract my 2c from both sides. This will get rid of it on the original side and leave me with just negative 40. 9c minus 2c leaves me with 7c plus 16. I still need to go about solving for c, so I'm trying to get it all by itself. For that to happen, I need to move 16 away, and in order to move it, I have to subtract. So it's going to cancel out and leave me with just 7c, and this is going to equal And when I combine negative 40 and negative 16, we get negative 56. The last step that we have here is to divide. And so when we divide both sides by 7, we get that c is equal to negative 8. So notice, not every solution that we'll get will be a special solution, but know that those are able to happen along the way. I'm going to take a look at number 7, and then I will give you the answers for example 6 and 8. So I'm going to kind of combine a couple of steps all at the same time. I know that I need to distribute here, but while I'm doing that, I'm also going to take a look at the left-hand side and see if there's anything that needs to combine together. I've got negative 13 plus 12p minus 4. And so my like terms on the left would be my negative 13 and my negative 4. When I add them together, I end up with negative 17 plus 12p. And this is going to equal 6 times 2p gives me 12p. And 6 times negative 1 is negative 6. Now I'm at a place where I need to get my variables on one side together. So when I subtract my 12p from one side, it ends up canceling out like I want it to and leaves me with just negative 17. But notice the same thing's going to happen on the right-hand side. 12 minus 12 leaves us with 0 p's and just leaves a negative 6 on that side. We know that negative 17 is not equal to negative 6. This is not a true statement. So our solution here is no solution. On example 6 and 8, for number 6, our answer for W is that W is equal to negative 2. And for number 8, we get that M is equal to 6. We're moving on. Let's look at the last couple of examples that we've got, and then we'll move on to the homework assignment at hand. So I'm going to take a look at 9 and 12. On 9, I have some distribution that needs to happen on both sides of my equation, so I'm going to get that taken care of right away. We have 16r plus 10, and then minus 3. This is equal to 16r minus 4 plus 11. I need to start combining my like terms, and I have like terms on either side. This 10 and minus 3, and negative 4 and 11. So 16r, 10 minus 3 leaves me with positive 7, and this is equal to 16r negative 4 plus 11 also gives me a positive 7. Notice we have that 16r plus 7 is equal to 16r plus 7. At this moment in time, I can see that both sides are equal, and because of that, I get an answer of infinitely many solutions. Now, if you don't believe me, had I continued to go, I would have subtracted 16 from both sides. They would have canceled on either side, and I still would have been left with 7 is equal to 7. We don't have to go that far to show that. So if you stop here, you're more than welcome to. If you continue to go, you're still going to find that you're going to get the same answer. Let's take a look at number 12. We have 7v minus 2v minus 16. And this is equal to 5v plus 4. So I'm going to go ahead and distribute. I've got parentheses to get rid of. The 5 is going to distribute here. And remember, when we don't see a number there, even though we have this sign, it is a 1. So make sure that if you need to see that there, you put that in. And then you're still going to distribute negative 1 to both things inside. So 7v is going to drop. I haven't done anything with that just yet. But negative 1 times 2 is minus 2v. Negative 1 times negative 16 gives me a positive 16. and I distribute my 5, and I get 5v plus 20. I need to keep going, so I'm going to start combining my like terms. And on the left-hand side, I do have two things that need to combine, these v's. So 7 minus 2 leaves me with 5v plus 16. This is going to be equal to 5v plus 20. Now, just like we did on number 9, we could stop at the red solution because we could notice that they were both equal on the same side. Well, if we do that here, and we try to look at either side of our equation, they don't quite match up. 5 is going to be equal to itself. That is true. But the 16 and the 20 don't match up. Because of this, they're not equal. And so because of this, we get a no solution. Now again, if you don't like seeing it this way and are not able to stop at this moment in time, we can still continue to solve by subtracting off the 5v, and when that happens, it cancels from both sides just like it had before. And I would still be left with 16 equal to 20. And even at this point, we still know 16 is not equal to 20 and still gives us the no solution that we had found. If you're wanting to know your solutions for 10 and 11, on number 10, we get that negative 24 is equal to negative 24, which gives us a solution of infinitely many solutions. And on number 11, when we solve towards the end, we would get that negative 9 is equal to negative 42. We know these two things are not equal, and because of that, this leaves us with a no solution. All right, well, that is all of our notes for today. So if we take a look at today's assignment, we're going to be taking a look at homework 7, equations with special solutions.